Supplies. One big cardboard box, one smaller cardboard box that fits inside the other cardboard box, old newspaper, black paper, aluminum foil, tape, 8 plastic rods, 4 mirrors, saran wrap, and a box cutter. Construction procedure. Step 1. Cut off the excess flaps of cardboard off the small box using the box cutter. Step 2. Crinkle up pieces of newspaper and line the bottom of the big box. Step 3. Put the black paper inside of the small box and tape it down. Step 4. Tape pieces of aluminum foil to the inside of the small box. Step 5. Place the small box inside the big box. Step 6. Crumble up pieces of newspaper like insulation in between the two boxes. Step 7. On the flaps of the big box, attach mirrors to direct the sunlight to your food. Step 8. Saran wrap the smaller box to create a greenhouse effect on your solar cooker. Step 9. Stick the plastic rods in the flaps of the big cardboard box to hold the flaps. Cooking procedure. Step 1. Obtain your food and place the food on the black piece of paper in the small box. Step 2. Place a thermometer inside the box so you can tell the temperature. Step 3. Cut a piece of saran wrap to cover the small box. Step 4. Place plastic rods to angle the flaps whichever way the sun is shining. Step 5. Leave the food until the food looks to be cooked all the way through. Step 6. Enjoy your tasty treat. Most solar cookers work on the same principle, that sunlight is converted to heat energy and retained for cooking. Here's how it works. The rays of sunlight go into the solar cooker. The aluminum flaps reflect the sunlight into the box, heating up the food. The rays of sunlight are then used to heat up the food. Now, you may be wondering, how does the sunlight get trapped in the box? Well, there are many reasons why this happens. One is, heat is attracted to dark objects, so the black paper retains a lot of heat from the sun. 2. The newspaper insulates the box, preventing heat from leaving the solar cooker. This keeps the box nice and warm. And 3. The saran wrap has a greenhouse effect on the solar cooker. This means that the heat is trapped inside of the solar cooker and has no way to escape. At the end of all these factors come and work together to cook the food inside of the solar cooker. Some ways that our solar cooker could have been better are if the flaps were bigger, so they could reflect more sunlight on the solar cooker. Another is the day that we cooked was unexpectedly windy. If we had picked another day that was not as windy, our stuff would have not blown away. We needed to make the flaps more bendable so we could point it at any angle to direct towards the sun. So our cardboard flaps were stiff, so they were hard to angle towards the sun. Another reason is that the insulation that we had put in did not fully cover all around the small box. If we added more insulation that was tighter and more compressed, the heat would retain better in the box and making the food even hotter.